Right, hello everyone. Hope we're all well today. As you can see, my environment is very different compared to what it normally is. I'm actually still at work. Um, well, I'm physically on site at work. So yes, the environment is slightly different. But I hope you're all well. It's great to see some of you have already joined this evening. We are going to get started in about, I'll give it until 10 past 5, just in case anyone decides to pop in a little later, a little beyond 5 o'clock. But today is going to be a really useful session for a lot of you. We're going to be going through a GCSE chemistry past paper. Now, I've decided to download an Edexcel and an AQA one. So depending on what people say on the chat, I will happily pick one or the other. But the skills that I'm going to talk through in going through the past paper will be comparable between the exam board. So don't stress if we decide to go with a different exam board to the one that you are revising for. It would be great to see some of you say hi in the chat. So by all means, do feel free to say hello. RT World, great to see you again. You've just said that you did your maths mock today and you're happy that you finished. I'm also happy that you finished, mate. I think that's absolutely fantastic. I hope it went well. So I'm definitely happy for you. Great to see you. Welcome back to our study squad. Great to have you here this evening. I hope you're excited to go over some chemistry this evening. That's what we're going to do today. It's going to be very exciting. Let's see. Also, just because I've gotten a few different resources, I did want to ask all of you what you wanted to do. I have a paper 1 paper and I have a paper 2 paper. I also have a foundation tier paper and a higher tier paper. So which would people prefer that I go over? Again, the skills that I cover will be comparable across the board, so don't worry about that. But it's just so people feel as though I'm addressing what they want me to address. So if you'd rather go over a foundation tier paper, then let me know. If you'd rather a higher tier paper, then let me know. So T-World, you've come in first with paper 1 AQA higher tier. So that's what we're going to do. I'm going to set that up really shortly. So we can hit the ground running. So that's going to be exciting. But yes, we'll give it another 4 or 5 minutes or so, no later than 10 past. We'll just get right into it. Also, while we're getting ready, can everyone let me know what they find difficult with past papers in particular? I am going to sort of talk you through where to find past papers firstly. I know some of you may not know, some of you may know. I will talk you through where to access past papers. I will give you a few names of some very useful websites and resources that I use for my students and I also use personally when I was preparing for my exams. And with that in mind, I will also go through the paper itself, invite all of you to answer some of these questions. And also give you feedback on what sort of things examiners look for. So some really useful tips. So I can see T, you said that answering the big marker questions and practicals are the hardest for you. Okay, so hopefully, and actually whilst I'm getting ready, let me just have a quick skim through the exam paper that I picked, just to make sure that the paper that I have had a practical question in there, at least one. But to answer your question straight away, again, we will address it when we get the paper going. With practicals, I think there are 2 things to keep in mind. Number 1, a practical question that you get may not exactly be word for word the same manner that you actually carried a test in school. A lot of GCSE papers and even A-level papers nowadays, what I'm about to say applies to both tiers. But a lot of the practicals are almost application-based, so the experiment may be very similar. So what's incredibly important is that as you revise, particularly your practicals, you make sure that you make the time to go through your practicals, to make sure that you really understand them, and you understand what exactly you're investigating. What are your independent variables? What are the trends? These are all really important, and you can apply them to those slightly more challenging questions. I can see that Samuel's also entered the chat this evening. Hi, Samuel. Good to see you. Hope you're well. Like I mentioned before, different environment today, but it means I can get here on time, because as you can imagine, navigating the M25 is always a challenge. Whilst I am just getting the past paper ready, just a few reminders for all of you. We do have 2 other brilliant study squads on a Monday and a Tuesday, so you can join Olivia on a Monday at 5 p.m. Goes over GCSE Maths. You can also tune in to Fliss's coding squads on a Tuesday at 5 p.m. also. So do make sure to check those out. And obviously you can check out mine on a Thursday at 5 p.m. This is getting towards one of the final sessions, actually, because we only have 10. And so this is number 8. So it has been enjoyable so far. And all I'll really say is I do hope that you found them useful, the sessions useful, and I hope that the skills that you've built over the past few study squads are ones that you will utilize as you continue. So let's see. Let's go for June 2020. That's a good one. AQA higher tier. June 2020 is the one that we'll look at today. Also today, the MyTeacher team were brilliant in setting up a lesson space for me to use, so I'll be able to use my little graphics tablet. As a bit of a disclosure, I cannot draw for my life at all, so any diagrams that I draw in advance, just be aware they're not Picasso standard by any means. But I can see some more people have joined us this evening. Good to see you all. Great to have you here. Okay, there we go. So we've got that, and we've got the mark scheme as well. Okay. T, you said thank you for the timetable the tutor gave. Really helpful. Great. I'm glad that you found it really useful. Okay, so what we're now going to do is we're going to upload this past paper. I think we should just get started. And then if anyone joins as we go along, then by all means, feel free to say hello and get involved. Hi, Emma. Good to see you this evening. Hope you've been doing well. Hope school's been okay. Hope mocks have been okay. Hope you've been using some of the study squad skills that we've been building up over the past few sessions. Let's have a look here. So where did I put it? On the desktop. Okay, that's fine. Okay. Let's see. Upload files. That's what we want to do. And we're just going to... Okay, so... just put a quick thumbs up in the chat if we are all ready to get started with this past paper. This is going to be an AQA paper 1 higher tier chemistry past paper is what we're going to be going over today. So by all means, you know, do put a quick thumbs up in the chat if you are ready to get started, and we'll just get right into it. Let's see. That's uploading. Okay, let's see. Okay, so worst comes to worst, if that doesn't work the way I'd like it to, I will just open it in Adobe, which might be more useful, to be honest. Okay, so T, I can see a thumbs up, so you're ready to get started. Fantastic. So I think with that then, right, let's move over here. So, past papers. I think, firstly, when it comes to a past paper, doing a past paper, it's important because it helps you apply what you have learned to a real life situation. Okay, to a situation similar to how you'll actually be assessed in the summer. Um, Now, writing notes is brilliant, and we've talked a little bit about the importance of putting together resources over time. But I do need to stress that ultimately, um, it's also important that you ensure that you take the time to go over past papers where possible, because writing notes isn't a substitute for going through a paper. Now, hopefully, all of you can see that. Just a quick thumbs up in the chat. Can we all see the past paper? Hopefully, we can. Can everyone see it okay? If not, then I will do a little bit of adjusting and just want to make sure all of you can see it. Hopefully all of you can. Oh, so this says, okay, so T has said, is this combined science? Because on the paper it would usually say combined science. Okay, so this is not combined science, this is the individual sciences. Did you want me to go over a combined science chemistry paper, or just, are you okay with me just going over a normal individual science paper? I'm more than happy to try and find a combined science paper if you find that more useful. Combined science, okay, not a problem. We will do that then. Okay, so if you just give me a moment. So, firstly, in terms of finding past paper questions, the first place that I would always go to is your exam board's website. So that's always free to access, okay? Now, for those of you who are studying under the AQA specification, just a quick Google search. The first is called aqa.org.uk. From there, you'll be able to then navigate to where you need to get to. So you can go to, and actually, I will share I'll share Chrome actually, so you can see what exactly I've got in terms of let me have a look. Google Chrome. There we go. Okay, great. So hopefully you can see that now as well, and actually this might work a bit better. Okay, there we go. Okay, so what you can probably see there, okay, you have your subjects. So if you want to find, let's say you end up on the AQA website directly, so we'll go there first. AQA, you click on subjects, then from subjects, you can then go to whichever subject applies to you. Now, I know a lot of you do combined science, so if you do combined science, you would just scroll down. Let's have a look here. You click on science. We've got science over here. You then have GCSE, biology, chemistry, physics. You have combined science synergy, and you have combined science trilogy. When it comes to you doing past paper questions, it's incredibly important that you pick the right code. Okay, if you are unsure which that applies to, do ask your teacher in school. Okay, because whenever you're doing past papers, in your own time, you want to ensure that you are marking your work against the same criteria the examiner will mark your work against in the summer. Okay, so do make sure that you do that. So we're going to go to Combined Science Trilogy, and then we are going to go to, so here you then have specification, planning resources, teaching resources, and assessment resources. So you can see that I've highlighted over that. We're going to click on assessment resources because we are preparing for an assessment. We want to make sure that we are ready for an assessment. And then from there, we are then going to go to this section where you can actually filter. Now, there are lots of files here, okay, and you can filter it down as much as you'd like. You can filter it by component. So we talked about doing paper 1 chemistry, so we're just going to click on that. And that's going to filter off all the other ones that we're not interested in today. So we're not going to look at biology or physics today. And from there, you can then see everything that just pertains to chemistry. Now, just as a quick show of hands in the live chat, how many of you know what the examiner's report is? Or how many of you even read the examiner's report? If you do, thumbs up. If you don't, thumbs down, or just say, I've got no idea what you're talking about, NK. What is the examiner's report? I've never looked at it. It'd be really interesting to see what you guys say. Do any of you know what the examiner's report is, or do any of you actually use it? Because if you don't use it, I'm going to talk a little bit about why it's important that you do use it, because the examiner's report is brilliant when it comes to revision. So, how many of you use the examiner's report when it comes to your revision? Okay, so T has said, is it like the mark scheme and what the requirements to get the question right are? You're on the right lines. Yeah, I would say that you're in the right ballpark as to what the examiner's report is. The examiner's report is really, it's a report from the examiner, but it's a nice, comprehensive document that details all the things that candidates need to do well on a paper, and will give explicit examples of why certain answers are good in the examiner's eyes and why certain answers could be improved on. I'm not going to say bad, but could be improved on. So it will point out which questions students did very well on. It will also point out questions that on the whole, as a cohort, students didn't do as well on. And it will then make recommendations to exam centres, so schools, to then focus on those areas for the next round of examinations. So if you don't use the examiner's report, then please start using it, because it gives real examples of what students do well at when it comes to answering questions well, and also even gives real examples of cases where a student hasn't performed as well with regards to specific questions, and it can help you identify some of the pitfalls that come with answering some of these past papers. So do make sure that you use it. The mark scheme is a list of answers and will tell you what you need to say to get the marks, but there's no commentary around that. So if you don't do it already, do use the examiner's report. Now, they're not always available for every exam series, but they're available for a good few of them. And not every question may be in the examiner's report within a paper, but you can apply recommendations from the examiner to any part of your past paper that you're doing. So please make sure you use it. So we are going to let's look at November 2021, and we said higher tier, didn't we? So we are going to open that in a new tab, and we're going to wait for that to load. Excellent. So we're just going to go through the paper. Okay, so we're just going to go through each question, and I want all of you to give as much input as possible. I want all of you to get as involved as possible also. Okay, now hopefully you can see that. You can see everything there. So by all means, do get involved. Now I don't want that there. I'm just going to zoom out a bit. Fantastic. Okay, hopefully you can see all of that. So let's start off with this question. Okay, this question is about the periodic table. Figure 1 shows part of Mendeleev's version of the periodic table. Which group of elements had not been discovered when Mendeleev's version of the periodic table was published? So what answer would you guys give here? Which group of elements had not been discovered when Mendeleev's version of the periodic table was published? So let's see, what answers do people come up with here? Do get involved, guys. I don't want to just give you the answers for the whole study squad session. So what do we think the answer is? Okay, so T, you said group 0 or group 7. Okay, so maybe 50-50. Does anyone have any alternative answers? Which group of elements had not been discovered when Mendeleev's version of the periodic table was published? So we already have, so T has suggested either group 0 or group 7. So, what do we think? What do we think the correct answer is? I'll give it a couple more minutes. And if we don't get any answers, we'll keep moving forward. Okay, so T, you're correct. It's group 0. Okay. Now you might be looking at this question and you might be thinking, well, how would I have known that? I think there are two ways in which you can answer these types of questions. Now, whenever I mark papers, I can always sort of classify a question based on it's either recall, pure recall, you either know it or you don't, or you can work it out. So it could be recall, okay, in that you just know that he hadn't sort of discovered those, but you can work it out based on the figure that you're given. Now, in an exam, as tricky as exams are, an examiner will never give you a piece of information that is entirely irrelevant. Sometimes it is just a case of determining what is relevant and what isn't. So here, if we look at this table, what we can do is we can look at what elements he has founded or discovered, and from there, then try and map them against the periodic table that we know today. And from that, we can then figure out what group is missing. So lithium and sodium are here. Now, what group are lithium and sodium in respectively? What do we all think? What group is lithium and sodium in the periodic table? If you don't have a periodic table with you, then by all means feel free to open up a new tab and Google it. If you've got a copy of it in your textbook, then by all means you can refer to that one as well. But what group are lithium and sodium in the periodic table? I'll give you a clue. It's not group 0 and it's not group 7. What type of elements are lithium and sodium? Are they metals or are they non-metals? And then from there, you can then probably figure out what the answer is likely to be. So T, you said 1, that's correct. So they are in group 1 of the periodic table, okay? So you know that group 1 is one that Mendeleev has founded, okay? And correct, T, they are also metals. Beryllium and magnesium, we know they're in group 2. Boron and aluminium are in group 3. Carbon and silicon in group 4. Nitrogen and phosphorus in group 5. Oxygen and sulfur in group 6. Fluorine and chlorine are in group 7. Those are your halogens, which leaves this gap here for your noble gases, so group 0. So whenever you do a past paper, even if you don't know the answer immediately, one of the bits of advice that I would give all of you watching is, firstly, try and remember the answer. If you can't immediately answer it, put a star next to it, fold the page and come back to it later. When you come back to it later, ask yourself, is there information here that can help me figure out the question? So with this question here, we could actually use that table to figure out the answer, okay? Them giving us this table isn't irrelevant at all. Actually, we use that table to help us figure out that group 0 was missing here and none of the other groups. And if you still feel that you really can't answer it, then at the very last resort, have an educated guess. And an educated guess is where you may eliminate other options, and then based on 2 final options, you then just pick one. There's a 50-50 chance. Does that make sense for everyone? Did you find that helpful in me talking through how you might go about answering those types of questions? Again, some of these questions may be a simple recall. You either know it or you don't know it. But some of these questions, you have cases where actually you can work it out based on the information that you're given. So that's what I would say there. So T, I can see a thumbs up from you. I'm glad that you have found that useful. Okay. If anyone else is feeling a bit too shy in terms of actually saying that they found it useful or not, then hopefully you have done. But let's continue with the paper. Let's see where we go from here. So this will be interesting. Figure 2 represents different models of the atom. Which model represents the plum pudding model? Now, I want to get a bit of engagement going on in the live chat. So, here, what is the plum pudding model? Okay, what is an example of the plum pudding model? What does it look like? Who came up with the plum pudding model? What are your thoughts? Let's get some discussion going on in the live chat. Or if any of you feel confident enough to just answer the question, then by all means, just say A, B, C, or D. Let's see what ideas we come up with. What are some ideas you guys have? Which one here is the plum pudding model? And for an extra mark, not that it's on the past paper, tell me why you think it's the plum pudding model. So T, you said that it's a ball of charge with electrons, and you said that it's B. Okay, so does anyone else have any other answers at all? Does anyone else have any other answers? We've had B so far. Anyone think it's C? Anyone think it's D? Anyone think it's A? Or are we all in agreement that it's B? If we're all in agreement that it's B, just put a thumbs up there in the live chat. Let me know what you guys think. So I think I would agree with you definitely. The answer is B. Okay? So here, we know it's the plum pudding model. And again, this is just recall. So your plum pudding model was essentially a ball of charge where they thought that the atom itself was positive and electrons were scattered on the surface. May, good to see you this evening. Glad that you also think it's B. Fantastic. Great to have the engagement, guys. I think it's brilliant. So we're correct. It's B here. Okay. Which model resulted from Chadwick's experimental work? So this is where we then have to think, okay, well, who was Chadwick and what work did he do? Okay, so this is another example of a recall type of question. Or you could work it out based on eliminating the other options. So what do you think the answer is here? Do we think it's A? Do we think it's B? Do we think it's C? Or do we think it's D? Which model resulted from Chadwick's experimental work? What do we think? So May, you've said A, very strong A there, okay? Does anyone else have any other options at all? We'll give it another minute and then we will move on to the next question after going over the answer. Just a minute to go. Okay, so T, you said you're not quite sure, so you're going to take a guess and just go with D. Okay. So, again, absolutely fine. We're using that, I suppose, educated guess technique. May, you said it's not strong, just also correct. Okay, well, I guess autocorrect has made your A a strong A. But fortunately, autocorrect has made your strong A a correct A. So the answer here is A. Now, T, I know you said the answer was D there, and that was a guess. Absolutely fine. And we're going to talk a little bit about why that was. So if we look at the other options, okay, D, atom model, that's your nuclear model, isn't it? So your nuclear model just states that you have the nucleus and electrons around it, okay? And that was determined from the gold foil experiment that Ernest Rutherford did, okay? Now C is Dalton's model. It's just a ball. There's no charge there. So that's the very, very beginning in terms of atomic history. Now we know the answer isn't B because B was the last answer. And the plum pudding model and Chadwick's model aren't the same thing, which leaves the answer as A. Okay. Does that make sense for everyone in terms of that explanation? Why the answer there was A Does that make sense? T, you're welcome. I'm glad that I was able to clear that up. Again, very easily done. Remember that Chadwick's model. The point of Chadwick's model was that electrons were found in the first place. Okay. D just shows that you have the nucleus. Okay, so that's the difference between the two. So I hope you found that useful. Okay, so let's move on in the paper. I want to focus on, let's look at 1.4 and 1.5. Now, out of curiosity, who finds calculation questions difficult and who finds descriptive questions difficult? I want to see what all of you say. Do you find description and describing questions more challenging, or do you find calculation questions more challenging? It doesn't matter either way, because we are going to go through both. I am going to give you some tips on how you navigate those types of questions. So by all means, feel free just to share what your experience is with past papers. So T, you find descriptions difficult. Okay, understandable. I think they can be quite challenging, especially when you have to write loads and loads. May, are you also the same? Do you also find describe questions challenging, or is it more calculations that you find challenging? So May said depends on the topic. I think that's absolutely fair. I think that's fair within chemistry, because some calculations are easier than others, some descriptive questions are easier than others as well. So let's start off with these descriptive types of questions. Now, one thing that I've developed is the question of, is the question a describe question, a state question, an explain question? Because there's a difference. Now, here, they're asking you to state something. What is meant by isotopes? So, can we agree that this is a state question? So you're just stating what an isotope is. Really what you're doing is you are writing down the definition as you would find the definition. Now the reason that's important is because whenever we have questions where you need to write things down, it is very, very easy to go off on a tangent and then start explaining. Okay? And unfortunately, in an exam, your answers are marked against a mark scheme, as all of you will already know. So even though sometimes some of the things that you say in your answers are absolutely brilliant, you can't be marked any extra marks for them for anything over and above what the question has asked you for. So it's really, really important that whenever you're writing your question, or your answers to the question, you ensure that firstly, you know what the question is asking you to do, and you ensure that your content is relevant to the question. So let's have a go at answering this question together. What is meant by isotopes? You should refer to subatomic particles. Now I want all of you to just have a go at answering that question. So just type your answer as you would write it in a paper like this. Just type it in the live chat and tell me what you think. And then what I'll then do is I will then mark your answer right now and tell you how many marks you would have gotten for that type of question. So, what is meant by isotopes? You should refer to subatomic particles. So what would your answer be here? Have a think about it, and then type your answer in the live chat. Let's see what some of you come up with. I'll give you 2 minutes, so we're going to work with a minute a mark. And then dependent on your answer, I will then tell you how many marks you would have gotten had you put that answer down in the actual exam itself. Okay, so May, you have said an element that has the same number of protons but a different number of neutrons. Okay, so May, for that answer, you would have gotten 2 marks there. So well done, very good. T, do you have an answer? Or does anyone else who has joined us this evening also have an answer? What would you have said in this situation? Don't at all feel pressure to maybe take inspiration from another answer that you've seen. By all means, just share. Okay, so, but yes, May, you would have gotten 2 out of 2 marks there. Because the question's out of 2 marks. So T, you said you were going to put that, but electrons at the end part. Okay, so here, so T, you would have gotten 1 out of 2 marks for that one. Okay, now the first mark in the mark scheme is just stating same number of protons. The second part is then saying different number of neutrons. Okay, now just talking a little bit about the chemistry behind that. Remember that isotopes have different mass numbers. And remember that from what you've learned and what you revised, isotopes have different physical properties. And physical properties are determined by the nucleus because the nucleus is what determines mass, which is a physical property. Your electrons are what determine your chemical properties. So the electrons will be the same, but the neutrons will be different. Hopefully that makes sense. Now, with these types of questions, what you need to ensure is that if they ask you to refer to something in your answer, you refer to it in your answer. Because you could say everything else around it that's absolutely brilliant, but if you don't state what they've asked for, it can be really, really challenging for examiners to give you the mark. Okay? So what was important here was to mention the subatomic particles, so to mention the ones that were relevant to the question. So because we're talking about isotopes, we're only thinking about protons because protons will determine the identity of the element. So we know that isotopes have to be the same element, and that's what the proton number and therefore the atomic number will determine. But neutrons are what make the difference because neutrons will determine the mass of the atom because your neutrons are found in the nucleus with your protons. Does that make sense? Give me a quick thumbs up if that makes sense to everyone. And hopefully, if I have clarified any misconceptions around isotopes, that's also cleared up too. So T, great to see a thumbs up from you. I'm glad that makes sense. And May, also glad to see it makes sense from you also. Fantastic. Now what we're now going to do is we're going to swiftly move along to looking at calculation types of questions. Now, I have no problem with you doing this calculation on your phone if you'd like. So by all means do so, or if you have a scientific calculator, by all means use that. Even more practice for you before your exam. So, I want to calculate the relative atomic mass of potassium. Based on that table, give your answer to 1 decimal place. Have a go at calculating that, and then tell me what you would have written down on your paper. Okay, again, approach this paper as you would normally do for a past paper. Calculate it, and tell me what you would have written down, and I will tell you how those marks are broken down. This is a 3-mark question. So 3 lovely marks up for grabs here in this paper. So, let me know what your answer is. Calculate the relative atomic mass of potassium. Give your answer to 1 decimal place. I'll give you guys 2 minutes or so. Again, don't feel the need to rush. And when you're ready, let me know what your answer is. I think calculations can always be a little bit challenging because sometimes you don't necessarily know how many decimal points to put down. So that can always prove to be a bit of a challenge. So let's see. I've also had a go at calculating this one. So I want to compare my answer to all of yours as well, just to make sure we're all on the same page. So what was the relative atomic mass that you guys got? You've got 1 minute left or so. Okay, so T, you said 0.8. Okay, I'm just looking at my answer as well. Let's see. Okay, May, what answer have you got in there? What was your answer? We'll give it another couple of minutes and then we'll go through the answers shortly. And don't worry, T, since you said you're not quite sure, I'll talk through a little bit about calculation. Okay, so May, you said that you haven't quite gone over this yet, so that's absolutely fine. So the correct answer here was 39.1. Okay, now we're going to talk about this a little bit. Firstly, what we need to remember about your elements are that the mass of any element is an average. It's an average of your different isotopes. So remember that different isotopes will have different mass numbers. And because they have different mass numbers, then your element that you see in the periodic table will have an average across those isotopes. Okay? Now, what's really important to remember is when we think about averages, particularly with isotopes, you also need to factor in how abundant those isotopes are. Now, in maths, for instance, when you do an average, you would add all your numbers up and then divide them by how many numbers there are. So if I wanted to get the average between the numbers 1, 2, and 3, I would add 1, 2, and 3 up, so that would be 6. And then I would divide 6 by 3, because there are 3 numbers, which would give me 2. Okay? However, I don't quite do that here. And the reason I don't do that here is because not all of the isotopes are found as equally. So you can see here that the isotope for potassium-39 is a lot more abundant than the isotope for potassium-41. So I factor that in. So the percentage abundance for potassium-39, okay, is 93.1%. So what I would do here is I would, let's have a look here. What I would do is I would, in brackets, write 39 times 93.1, close bracket, plus 41 times 6.9, close bracket, over 100%. Because in doing that, I'm taking the average, but I'm also factoring in that the different elements have different abundances. And that's something else I need to factor in when it comes to me doing the calculation. Okay? Does that make sense for everyone? May, I know you've not quite gone over this yet, so it may make sense now, but it will make more sense when you go over it in school or when you revise it independently. T, does that make more sense for you as to why the answer isn't quite 0.8, but rather it's 39.1? So whenever you're doing your calculation, just make sure that you factor in that abundance. Okay? Now, what I am going to do is I'm going to write that out so that it makes a bit more sense. So if you just give me a moment, let's have a look here. So, let's see. So we're going to go over here. I'm going to switch over to the lesson space so you can see what I am going to draw. So there we go. So hopefully you can see. Okay, so Chrome is there. There we go. Okay, fantastic. So I'm going to close that. Okay, fantastic. So I'm going to add a new page. So in terms of the actual calculation, what I'm going to do here is I'm going to type, oh, hang on. Let's type this out. So I'll type here 39 times 93.1 plus 41 times 6.9. I'm just going to make that a bit wider. Oh, hang on a second. That's better. Over 100. Okay. Now the reason I've done that calculation for this question, we know that 39 and 41 are our relative atomic masses. Okay. Now it's important that we add those in because we want to find out what the average is. But we also need to factor in the fact that I have more of the 39 isotope than the 41 isotope. If I were to not factor that in, and I just did 39 plus 41 divided by 2, then I'd get 40. But doing that calculation makes the assumption that the isotopes are in equal abundance, and we know that they're not. Okay? So in reality, what I need to do is I just need to factor in that this isotope, 39, is more frequent than this isotope, 41. And so by factoring in those percentages, I factor in the fact that one isotope is more abundant than the other. Does me typing that out make a bit more sense? Does that clarify things a bit more for both of you and for anyone else who's listening this evening? Does that make sense? Hopefully it does. What I will do also is it does make sense, fantastic. Great to hear it, T. And glad that it makes sense for you also. Now what I am going to do is I'm going to switch back over to the PowerPoint, the past paper. So if you just give me a moment. There we go. Fantastic. So let's go back over. Oh, it wasn't there, was it? It was on Chrome. There we go. Okay, so we're going to go back over here. Fantastic. Now, I'm conscious of time, so what I do want to do is I want to go over one practical question and one of the longer mark questions as well. Okay. Now, this practical question is about zinc carbonate and the reaction with nitric acid. They give us a word equation here, and they ask us to give two observations. Now, from an examiner's perspective, there are two things I would always keep in mind when it comes to giving observations. Number one, an observation is something that you would see, and that needs to be taken quite literally. So one thing that's quite often put down is I would see something react. Well, you might see it react, but what does that actually mean? So do you see fizzing? Do you see bubbling? Do you see something disappear? If any of those apply, then write those down, okay? Because anything else isn't an observation. If you see a color change, write that down, okay? Number two, your observations need to be distinct and they need to be separate. So one answer can't be interpreted for the other, okay? So here, for instance, with this question, they want us to give two observations that would be made when zinc carbonate is added to nitric acid. So we could say here the white solid disappears, okay? And the second thing we could say is that we would see bubbling. And the bubbling would come from the production of carbon dioxide. But what we need to remember is that you can't say, I would see carbon dioxide being produced. Because strictly from observation, there's nothing that tells you that it's specifically carbon dioxide being produced. What you would see, though, is a gas being produced. And that's the difference. Does that make sense for everyone in terms of observations? Yeah? So in terms of your mark scheme, you could have said the white solid disappears, you see bubbles forming, you could say that it then maybe stops fizzing at the end of the reaction, you could say that the solid left at the end, possibly, if there is any solid left at the end. So all of these things are important. So with your observations, do make sure that you say what you see. You don't explain the observation because the two are totally different things. Okay? Let's scroll down. Perfect. Here's a good experiment question. So here's one that talks about you planning a method to produce a pure dry sample of the soluble salt copper chloride from an acid and a metal oxide. Now, on a scale of 1 to 10, how confident do all of us feel about these types of questions when it comes to investigations? How confident are we? With 1 being the lowest and 10 being the highest, how confident are we all? And then shortly I'm going to talk a little bit about some of the tips that can really help you with these types of questions. So T, you said like a 3, that's absolutely fine. Hopefully by the end of the study squad, you will feel like a 6 and above. So I don't know, I said an 8. Okay, well that's fantastic. I'm great you feel quite confident in answering these types of questions. So hopefully everything that I'm going to say is going to feel quite routine to you. But you might pick some new things up here and there. And then May, you have said 5, so somewhere in the middle. Now, I'm going to say, with your experiment types of question, where you're asked to plan a method, what you want to do is you want to state things as if you're writing down a set of instructions for someone else to follow. So every point that you make, break it down, break the method down into easy to follow steps in which you would state what apparatus you need. So with every step that you write down, ask yourself, why am I performing this step? What do I need to complete the step? So if we start with this question, they want us to plan a method to produce pure dry samples of the soluble salt copper chloride from an acid and a metal oxide. So what we could do if we look at, well, it's not exactly this investigation, but what we could do is we could ask ourselves, okay, well, we want to form copper chloride. So what will we need? Well, we'll need something with chlorine in it, so hydrochloric acid, and we're going to need something with copper in it, so maybe copper oxide, okay? So that's your metal oxide and that's your acid. So saying those two things would already be a mark because you have pointed out your 2 reactants that you would need, okay? Then ask yourself, well, where am I going to react them? In a beaker of some sort, okay? The third thing you might ask yourself is, what conditions? So what do I need? Where is it going to happen? What conditions? What apparatus? So you could ask yourself, well, in terms of conditions, do I need to warm anything up? So you could ask yourself, how could I warm up the hydrochloric acid? You could get a water bath, for instance, and you could heat up a specific volume of hydrochloric acid because we shouldn't be heating up acids directly with a Bunsen burner at the risk that you have spitting, boiling acid going everywhere, which is a hazard. You could then say that you're going to take a specific volume of hydrochloric acid, and you could say that you're going to add your oxide spatula by spatula. So I don't know, has said don't we use crystallization? So we do use crystallization, but remember that crystallization comes at the very end of the experiment. Okay, so this method is crystallization, but that would come after you have added your oxide to your acid, you have made sure that they have reacted entirely, and then you would wait for it to crystallize out and then dry it out, pat it down, etc. So that would come at the very end. So even though the method is crystallization, what's really important is that when you're stating what the steps are, you make it clear how you get from the start to the finish. Okay. Interesting. So you said that you lost 2 marks in this question. So, whenever it comes to answering these types of questions, and I can see that we're really short on time, unfortunately, so I'll apply what I'm about to say to longer questions as well. Always imagine that you're explaining it to the examiner because the examiner does not know what you're talking about. Okay? Exams are a brilliant opportunity for all of you to really show off what you've learned. Okay? Don't make assumptions that just because the person who's marking your paper may be a science teacher, it doesn't automatically mean that if you say crystallization, they'll say, okay, yeah, that's 6 marks because they know it's crystallization. The question has asked you to plan a method to produce pure dry samples of copper chloride. So yes, you're correct, the method is crystallization, but they want you to discuss what that involves. So everything starting from having a beaker of hydrochloric acid and your solid copper oxide to ultimately having those copper chloride crystals going from start to finish. Okay, really, really important that you break down your answer as much as possible. Okay, now does that make sense for everyone? Because I'm aware of the fact that we are running a little bit tight on time today. Did everyone find me going through a past paper useful? Would anyone like me to go over a past paper next week? And if so, is there a specific type of past paper that they would like me to go over? That's either biology or chemistry. Oh, fantastic. I'm glad that you found it useful. So I don't know, I said Wednesday. Unfortunately, my study squads are on Thursdays. Unfortunately, they're on Thursdays. So I can't really do Wednesday, unfortunately. But I can only do paper 2. Would that be paper 2 for chemistry as well? Because if so, then more than happy to do that. Oh, you've got your mock on Thursday. Oh, that's really, really annoying. Okay. So I suppose you can still join the study squad either way, because you may pick up some skills that you can then apply for your real exam. So by all means, do join next Thursday all the same, even though your mock's on the Thursday. But we can certainly do that next week. We can go over a paper 2 chemistry paper. And I will try and... Oh, okay, so T, you've also said biology paper 1. So we'll do half and half. We'll do biology paper 1 for half of it, and chemistry paper 2 for the second half of it. I think that would be fair. So that's what we'll do next week. I did also want to talk about making notes, but if people feel as though me doing a past paper would be useful, then I'm more than happy to go through a past paper and sort of discuss some of the some of the skills that you can utilize in your paper. But I will make some time to talk about how to write effective notes regardless. So that's also fine. I'll integrate the two. Oh, we can do Chem the week after. Okay, that's absolutely fine. So yeah, we can do that. Fantastic. So that concludes the end of the study squad. Now I will hang around for 5 odd minutes or so. If anyone does have any questions, then by all means, you're more than welcome to ask them. Like I always say, there is a survey that will be put in the live chat really, really shortly. It's a live chat for feedback. It's really, really useful to us at My Tutor if you let us know what you thought of the study squad this evening, whether you found it useful, whether you didn't find it useful, and what we can do to improve them to make the experience more useful for you. So there should be a survey link that's posted in the live chat at some point. So by all means, make sure that you fill in the survey before you leave. Also make sure to join again next week at 5 p.m. There is a link as well where you can be reminded that the live stream is at 5 p.m. on a Thursday. So in case you do forget, you can get a nice little reminder to say, hey, make sure you join next week at 5 p.m. But I hope you all found this evening's study squad useful. I don't know, you've asked, can we specifically go over quantitative chemistry? Yes, that's absolutely fine. More than happy to go over quantitative chemistry. Is there anything in particular with quantitative chemistry that you want to go over? Is it maybe acids and bases types of calculations? Is it titration calculations? Is it moles? I know those pesky moles questions can always be a bit challenging. I know I found them quite challenging. Reacting masses. Okay, we can certainly go over reacting masses. That is not a problem. Absolutely fine. T, you are more than welcome. I'm glad that you found it useful. I'm glad you found it really useful. And I know chemistry can be challenging. It can be a very challenging subject. So I'm definitely glad that you found the session helpful. And it could very well be that we restructure the last few sessions of the study squads where we just sort of focus on maybe biology and chemistry past papers. And we focus on how you can use past papers to really to better how you study. Although I do have some other bits to talk to you all about. So about how to balance your time. So in the next few sessions, we'll do a bit of both. But you're more than welcome. May, you're welcome as well. Thank you for joining this evening. It's been a pleasure. And so I don't know, you said that it's reacting masses and you want to go over the maths bit. Just double check, is that right? You want to go over the maths bit for reacting masses? So next week what we'll do is the maths bit, fantastic. So next week what we'll do is for the first half, I want to talk to all of you about the importance of time management and about balancing things. Because I know that can be quite challenging. Actually, that wasn't my plan. My plan was to go over note-taking. So for the first bit, I'm going to discuss how you can make your notes more effective when it comes to revision. And then for the second half, we will go over some biology. And then the week after, which I actually think is the last study squad session, we will go over how to manage your time effectively so you don't burn out. And then we will finish off with a chemistry past paper. So do make sure you tune in for those other study squad sessions because they will be the last ones, which is quite sad actually because I've actually quite enjoyed them. But hopefully these are live streams that my tutor continues with because the engagement's been absolutely brilliant. So, and if you found them useful, then by all means, I definitely want to continue them. But I think that is okay. So I don't know. You said that you feel like writing notes in year 11 is pointless because you feel like you should use save my exams and physics and maths tutor notes and only make online flashcards. Okay, interesting. So I will talk a little bit about that in next week's session. So writing notes, obviously everyone has their own sort of style. For some, writing notes isn't useful. Sometimes just printing off notes is more effective. But there's no reason why you can't do a combination of the two. So you could print off notes from certain resources and then annotate over them so that you make them personalized so that they work best for you. We will talk about that next week. But point made, that you do have other alternatives than writing your notes from scratch. So we will discuss that next week. But I think that is everything from me for today. I hope all of you have a lovely evening. I hope all of you are continuing to work hard. I'm sure all of you are. Make sure you give yourselves a pat on the back for all the hard work that you do at school. Because I know GCSEs or A-levels, they're always a little bit challenging. But I'm sure that you're trying your absolute best, and that's the most important thing at the end of the day. But otherwise, have a lovely evening. I will see all of you next Thursday at the same time. Okay, so I'll see you all at 5 p.m. Thursday. Like I mentioned before, make sure that you tune in for half the session being about how to write notes more effectively, and then we're going to go straight into a biology AQA paper 1. So best of both worlds session next week. But otherwise, I will see you all. But take care till then. Have a lovely evening. Take care. Stay safe. All the best.